Thanks for coming. My name is Savvas. I'm a senior software engineer at Shazam. You can find me at Geeky Android at Twitter. And I'm here to talk about preventing analytics and ads from polluting your codebase. First of all, this is an Android talk. How many of you are Android devs or interested in Android? Okay, a few. I forgot to mention that in the title, so sorry for those that came to the wrong talk. How many of you have actually had to deal with implementing analytics in your codebase? Page views, user events? Okay. How many of you had to work with ads? Same amount of people. How many of those people had to change their ad provider at some point in the future and had to spend a couple of weeks battling the different SDKs and swearing the moment they had to? Good. We had to do the same thing a couple of times actually, and the last time we had to do it, it only took us a day to implement a new provider. And I'm going to show you how we did that. Of course, we're, as the keynote speaker mentioned, I don't know if you have been to the keynote today, but we are devs, we love to reinvent the wheel. So what we did is we wrote a library that was missing from Android that does aspecting. Have any of you have heard the word aspecting, aspect-oriented programming? Okay, a few. So what is an aspect? Using aspects, you can apply behavior to classes without having to modify their source code. And aspecting is very good for cross-cutting concerns, such as analytics and ads, because they're not really part of your business logic. If you think about it, sending a page view event doesn't have to do anything with whatever app you're building, or displaying an ad. It's an unnecessary evil, necessary evil. I hope it was unnecessary, that you have to do. So how do we do these things? How many of you had to extend an activity when you had to integrate with a third-party library? No one. Okay. So there's this thing in Android that many third-party libraries expect you to extend from a parent class, either an activity or a fragment, to get some behavior that they provide. And that's okay and everything, but the problem happens when you want to integrate with two of these libraries, and they both provide their own behavior, and your class needs both of those behaviors, and of course you end up with a known diamond problem. And Android is very, very guilty of this. Android was built at a time where the devices were really inefficient. There was not a lot of processing power. So they focused more on performance than getting their APIs fluid and things that people have enjoyed in the desktop and the server world for years. So the concept of inheritance is very permeated throughout the system. Composition is not really a thing that Android does. So we decided to come up with a solution for this problem using aspects, and what we ended up doing is creating another activity that you guys will have to extend. But hopefully that will be the only activity that you will have to extend. Now, by doing this, you can apply behavior to classes from many libraries without having to extend multiple classes. This library is called Android Aspects. You can find it on GitHub on this link. And it works with fragments, activities, in your application. Just one moment. Right, so how does that all work towards that preventing your analytics and your ads from polluting your code base? I will show you a small example. It's a contrived example, of course, but it demonstrates the concepts very well. I'm going to switch to code now. This is a live coding demo. So I hope the screen resolution will be enough. Right, let's see. Can everyone read this? No, okay. So I may have to change presentation mode. How about now? Cool, all right. So I will speak to you. I'd like to talk about the idea of having static aspects, statically configured aspects, dynamically configured aspects, and how you can have aspects talking to each other to have interoperation between them. I'll start with a very small example. This is an app that has two screens. The first screen launches the second screen, and there's nothing to it. It's literally just that, as you can see here. There's a click listener that starts the second screen. And we want to create page view events for these screens. When they started, when they stopped, how long it took. The app, I think I've deployed here, is very simple. It's not there. An activity, you start another one, and you get another screen. Very simple. Now what this did is, oh, this is interesting. I may have to exit presentation mode for this to show. So, you see these three lines here. Activity started, activity stopped. Page view lasted 2,365 milliseconds. Now you may notice that there's nothing in this code that specifically does page views. It's setting a content view and a click listener. All the magic, of course, is here. Okay, I may have to increase the font a bit. Come on. There it is. Right. So yeah, all the magic is in this line. You can see that our activity extends from the aspect activity. We provide aspect versions of all the well-known activities, the aspect activity, fragment activity. We have coming in, I haven't actually pushed this code yet, but support for the new app compat activity. Also works for fragments and for applications. What this does is it says that apply this specific aspect to this activity. This is a very simple aspect. An aspect basically has all the callbacks that an activity or a fragment has, and you get to implement whatever you used to implement normally on an activity or a fragment, but not by inheriting from that class, but by getting that class passed to you. So you can see here in the onStart callback and in the onStop callback, I'm counting the time between these two calls, and of course I'm logging out the fact that a page view happened. Of course, this is a contrived example. In your actual application, you would have an integration with Google Analytics or with Flurry or with whoever you decide to do analytics with. Now, this extends from a class. There's no need for this. There's an actual interface for this. It's called an activity aspect. But extending a no-op version means you don't have to implement all the methods. This is applied automatically for you. You don't have to do anything. The aspect activity takes care of everything. This is, of course, a very simple example, and there's nothing really interesting you can do with these things. Like, there's a very few examples that having something statically applied to your class can give you some, benefit. This does the same thing for both activities. As you may have seen in the logs, they both say activity started. You don't know which activity started. You have no context, basically. So next up, I would like to talk to you about static configuration. So you may notice that something's changed here. Aspects are retrieved by recursively going up the tree of the object hierarchy until all the annotations have been found. So you can create your own custom annotations that provide aspect behavior. If you do that, you can apply configuration to them. If you notice, this is a very simple annotation that also is annotated with the aspects thing. So this was coded, this was applied to the class before, it is now applied to an annotation, and you can apply that annotation to your code. What that lets you do is provide methods that let you provide configuration for this aspect. Here I have another aspect class called named pageview, and as you can see, the annotation with pageview provides a string. So when you annotate your class, you can say this screen is called main. I have the same thing for the second screen called second. So the named pageview aspect does the same thing, starts and stops, but now when it's created, it overrides the onCreate method. It pulls the with pageview annotation from the object that was annotated and gets the page name. So now it can provide context around what the pageview was. And I can demonstrate this by running the class. Okay, there you go. You can see activity main started. Open the new screen. Activity second started. Activity main stopped, and the page view lasted. you can get crazy with this. You can create as many complex customizations you want or configurations. For instance, in this case, I don't know if you've noticed, but the second activity started log came before the first activity stopped. That is, of course, because we overrode the start-stop methods. And as you may know, the stop on stop method gets called after the on start method of the new activity has been called. This is a weird Android interaction, but you can remedy that, of course, by going into the pause resume callbacks, or you can configure that. You can choose which of the two callbacks you want. And I'll show you how we did that. I'm not going to show the entire code here. There's a lot of classes that, if this decide, yeah, you can see there's a lot of hierarchy there. But basically, the idea is that instead of doing the actual work of the page view in the aspect, you use a strategy pattern. The strategy pattern gives you callbacks between start and stop, or pause and resume, and the work of the actual page view is done by Collaborator. In this case, it's a session manager. You can see here, you can also provide on the page view the strategy you want. You can say the page name is main, and the strategy is resume pause. You have an enumeration here, start, stop, and resume pause. And of course, you can provide defaults. The annotation now looks like this. The start, stop is the default behavior. The good thing about this, I mean, even if there's no need for such deep customization, the good thing with using this pattern is, if you can see, the page view now gets called properly. Start, stop, as expected. Using a strategy and delegating the work to a collaborator means that now the collaborator can be unit tested. Because, if I can find the implementation. There you go. This class is now a Java class. There's no Android code here. There's no Android aspects code here. This is a pure Java class. You can do integration tests or unit tests or whatever you want. And also, the domain model now is geared toward what we're doing. You see there's a method called start page view and stop page view. So I can unit test my business logic separately and tie that into my view logic, the activity, with the aspect. Testing the whole integration can be a concern of an end-to-end test. So you can test the valid use case of one page view being sent, listening through a fake server, or looking to the logs, depending on how you implement your system. And once you've tested that happy scenario, then you can unit test the session manager to your house content. You can catch all the edge cases. You don't have to go through a really slow cycle of writing and executing acceptance tests. Of course, that is also a bit contrived. Yes, okay, we have names for the page views, but what about the page itself? Like, what was the data that we loaded? Like, this is a very simple example. It displays literally nothing. So I created a very small, business value for the app. The app will now display track IDs. So, coming from Shazam, we have the concept of you launch a screen and you look at the details for a track. So now the app looks like this. Well, if it loads again. There you go. So when you start a new screen, I haven't actually visually added this yet. In the next example I will, but that screen now contains the ID of the track you would like to load and display the title and image for. You do this, obviously, by passing the data across. This is normal Android stuff, nothing special here. I'm passing a parameter into the intent, and then I'm parsing that intent in the second screen. So I'm getting the track ID. I'm not doing anything with the track ID here, but here you would do your normal business logic of loading the track from the network or from your local persistence and display whatever you need to display. Now we would like the page view to contain that track ID because it's important when you can see, for instance, 50,000 people have loaded Madonna's track today or something like that. This already does it. If you can see here, I know it's a bit hard to read, but I'll read this out. It says page view started, main. Main doesn't contain any extra data. Page view stopped, main, duration. Page view started second, but if I leave, page view stopped, duration, and parameter track ID. You see the track ID is now in the page view. How did that happen? So the with page view annotation applies an aspect which not only looks for the page view annotation to get the page. You may also notice that I've introduced an object here instead of a simple string. It's always a good idea to put domain objects instead of simple raw data as a string, and it will be apparent in a bit why I've done that. That aspect is also looking if the object that was annotated implements a specific interface. In this case, we've called it page view configurator. Terrible name, but you can find something better. That interface is very simple. It allows you to configure the page that you've specified. It's a generic interface, and we also have a very small interface called page that you can use. Instead of the string, you can provide a page, which gives you a page name. And there's also a list of a map of parameters. These are additional data that you would like your page view to have. This specific page that we created, called second page, provides the page name and extends configurable page, which literally just gives you an access to add parameters to that map. So when the second activity gets that callback, it will add the parameter track ID to that page. And when the session manager gets hold of that page, I will show you how that has been modified now, it will blindly get whatever parameters was passed into the page object and also send them into the page view. In this case, the session manager looks very similar like before, but now, instead of pulling a string from the annotation, it pulls the object page. Same thing as before. Instead of saying, let me implement that, you look for the annotation, you create the page, because these are all, remember, parameters in an annotation, so you can't provide instances here, you provide a class. And this is the bit that this specific example doesn't do very nicely. It does a simple instance of check, but you can use any techniques that you know to avoid these things. This was a crude example to show how you can do this. This says that if the object allows me to configure it, I will call that method on that object. And that is it. There's nothing special to it because the parameters are added to the page object. When the session manager sends the page view here, it will do the normal thing of saying what the name is, but will also add all the parameters into the page view. Like in our case, for instance, this would be a call to a custom API that we have, and all the parameters will be query parameters on the URL. In Google Analytics, it would be Google Analytics has a way to provide them into a map. Flurry has its own thing as well. Now, this is dynamic configuration. This can be really powerful, but it is a bit messy, mostly because you have to implement custom interfaces and you have to do that weird work of delegating the calls. Now, how does that apply to ads? We've talked about page views. This is also about ads. Ads are surprisingly similar to page views, if you think about it. An ad, you have to configure the ad when a screen appears. You have to configure with some data, and then when the user leaves the screen, you have to tear down the ad. You might have to do some custom logic to tear it down. So in that case, in that sense, it's very similar to what I've shown you so far. I haven't integrated with a custom ad SDK here, obviously, but the ideas are all the same. You have an ad view. You give it a map of keys or a list of strings that are basically keywords that then the ad provider can use to target ads to your use case. So in our case, if we were loading a track from Madonna again, I would put the word keyword artist, value Madonna. So the ad provider would know that this person is interested in music. So I need to provide them with music-related content. The concept is very similar. You start an ad, you display an ad, you tear down an ad. The way we do this without modifying the code of the activity is where we use configuration, sorry, not configuration, we use the idea of implicit, contract basically. We have some contracts that we've said. We've said that our activity will contain a view called with the ID r.id.advert. This is something that we chose for this specific example. And our aspect will try to find that view. It will get a hold of that view. It will do its usual thing on start. It will configure the ad provider. It will use a callback to let the screen configure the ad itself. And then on tear down, it will do something similar. Now you see the second activity here, the second screen, now contains a fake ad. That green thing in the bottom. I haven't integrated with an actual ad provider. I've created a fake version of that, but the implementation is not specific. It's not important in this case. You can see the ad here contains a key called second page ad ID. That is done exactly the same way as before. We have a custom annotation called with ad, and it takes the name of the page, exactly like we did with the page view in the first iteration. And that aspect has an ad binder aspect. And that ad binder tries to find the ad in onResume. It will try to find the ad view, configure it. This ad configuration here will be an abstraction that comes from either your service or from a local hard-coded configuration that basically maps screens to keywords. All the ad providers have this concept of either a site ID, it's called, or a zone ID. So basically you say, you define IDs for every screen in your app, but you can have multiple screens share the same ID. So this is what this does. And then you load the ad. That's literally it. I'm not doing any teardown here, but you can easily, if the ad provider required a teardown, I could go on detached from window. I get a callback. Another note here, I don't need to actually call super like you usually have to do on Android, because remember, this is an interface. I'm not extending an activity here. So yeah, and then with the activity, I can say add view. I don't have the add view as a field, but I could have the add view as a field when I pull it out. And then I can say destroy or something and pass the activity to it, so I have the context. And you can do the teardown that you need at that point. Let me get rid of this. Cool. So there's nothing special about ads. They're the same beast as page views. Ads also need dynamic configuration, like we said. This was static configuration that came from the server. Another example, like we did with the page view, would be to let the second screen provide the track ID as a keyword, exactly like we did for the page view. So now the second activity will implement the ad configurator interface. Very similar to before, you are asked to configure the ad through an ad facade. This is an interface, so you don't have to actually pass the ad view down, and you add keywords to it. The code is exactly the same like before. I'm not going to go run through it. It's a bit pointless, but I will demonstrate the fact that it will work now by loading the ID into the ad. And the good thing about this, of course, the whole point of why we're doing all that work is that this aspect can be applied to 20 screens of your app. So now without changing the code, you basically have the same behavior in all of them. Also, aspects can be, as you saw in this example, a number of aspects can be applied to one activity at a time or one object. You see here we have the page view and the ad at the same time. You can have 20 of them. Using the original aspect annotation, you can provide as many as you want. You can provide a list of them. So because they're traversed in hierarchy, you can also subclass these activities if you have to, and provide your own. So for instance, you can have your own base activity. If you want some behavior to be applicable to your entire app, regardless of which screen, you don't want to have to go and add an aspect to all your activities. So you can have your own base class that extends from an activity and apply this aspect. The other good thing about using custom annotations, creating your own annotation aspects basically, is that you can provide a list of aspect interfaces, implementations of that interface, that provide the same behavior for different classes. So for instance, a page view. A page view can be applied to an activity, but say you have a main screen in your app that has 3 tabs, and those tabs are fragments. And you want those page views as separate, you want those fragments to send out a separate page view. Your activity no longer works for that. You want the page view aspect to be applied to the fragment. If you create another aspect here that works on a fragment, you can apply the same interface on an activity or on a fragment, and the system will pick up the right aspect for it, because the aspect interface has activity aspect. There you go. It has the idea of the class that this aspect can be applied to. So you can create an aspect that applies to all the fragments, the normal fragment, the support fragment, and the app compat fragment, and applies to activities, and apply the same annotation to all of them, and it will look the same, and it will behave exactly the same way. We've done this in our app because our main screen has three tabs, and they're all fragments. So we use the same annotation with pageview, and it works for everything. So next up is to show you how that actually interacts with your business logic. Like, everything is nice and clean, but the classes that I've shown have actually no business logic in them. How does that look? So we will modify our app to display a list of tracks on the first screen, and then you get to choose the track you want to open for the second screen. Right? So this is loading a list of tracks. You can choose which track you want to open and load the track. Now you can see I have a buy button there in both the screens. Let's see how that looks. The main activity now has some more code to it. Still no business logic though. How many of you have heard of the MVP pattern or used the MVP pattern? A few people, that's good. So on Android is notoriously difficult to test. So we've always had this problem because the tooling is not there, the speed is a bit slow. You don't want to do this. You want to test Java code because we know how to test Java code. It's been a well-established matter. So we separate the business logic of our app to a presenter. We have the view, which is our activity, talk to a presenter, let the presenter do the business logic, fetching the track, deciding which track to load, and then have the presenter display data into the view. So in this case, we have the main presenter. I'm not going to go into detail about this because this is a talk about MVP, but the presenter here is very simple. It uses the abstraction of a fetcher of data. It fetches some tasks. The implementation in this example is backed by object loaders. So you get nice problems with, like, if you rotate the phone, you don't get those weird problems that Android usually has. You fetch the data, and when the data is fetched, you let the view know that you've loaded a list of tracks. Of course, this is a very simple business logic, but all the actual code would live here. This is pure Java. There's no Android dependencies here. You can unit test this to your heart content. Everything is an interface. The main view is an interface that the activity implements. So the activity is told to display a list of tracks. Now the idea with this is that your views should be as dumb as possible. There should be no logic in your views. No if statements, no weird null checks that have to do with your domain. Now you have to do some null checks, unfortunately, because Android gives you null views or null intents and stuff like that. But you shouldn't have any business logic in your activity. By doing that, you move all the logic to the presenter. The activity is very tiny. You use all your cross-cutting concerns in aspects, and most of the activities that you write should never be more than 100 or 200 lines maximum. And you can make them really complex. Like, we have some activities that do crazy things, and they are about 250 lines, basically. That's the idea. And of course, the reusability of the aspects allow you to do complex things in one place and apply that across many screens, which is what we use for the ads. So when we had to switch from an ad provider to another ad provider, we only had to change one class because we had the abstraction of the ad view. When we changed the providers, we implemented a different class, hooked that into our dependency injection system, and everything worked. All our acceptance tests worked. For page use also, we had the abstraction of the session manager, as I've talked about. That the business logic of that was also pure Java. So that was unit tested. We had to change, we haven't actually yet, but if we have to change the implementation of our analytics engine, all we have to do is implement that interface of a page view, like what does a session mean, and everything will be tested and it will be working. This screen, as you saw, has the added functionality of having buy buttons. Now I'm going to show you what happens when I press a buy button. Oops, wrong class. Buy button. Right. So I have the concept of an event analytics engine here. This is again an abstraction. This is for user events, like we've shown page views, but most of the time page views are very simple to do. User events are a bit tricky because you have to have data at the point of the action, plus the context around which screen were you in when that action happened. So in this case, the data that we pass into the event, we say this is a user event and the type is a button click. The track ID can be passed as data because the button itself has to bind to that data, right? So you have to tell the button, when you're clicked, launch the Amazon App Store for this track. So the button knows that already. That is given by the adapter. So when the adapter gets a list of all the IDs, it binds to all the buy buttons. Of course, I haven't implemented the click to send you somewhere, but the event analytics works. So if I filter for that event, this will be called event now. You see, if I go to the main screen and I say, buy the Smells Like Teen Spirit, I pressed it, I get an event type of user event with a track ID that was provided, and the type was by button click. The class is the same, obviously, so if I click a different button, the track ID will be different, and that is because the data is bound inside the view. That's very simple and obvious. But unfortunately, that doesn't always work, because, okay, same thing. If I go to the secondary screen and press the buy track, I get the same event. And that's the problem, because that buy button does the same thing. The data is exactly the same, because they both share the same track ID, but you don't know what screen did the user press the button on. And yes, you could put that data down into the actual button view when you construct it. That's what we used to do, and it became really, really cumbersome, because every time you had to add some additional data to an event that came from the screen that you're on. So for instance, sometimes you need to press the share button and need to send an event that the user pressed the share button. And at that point, someone says, oh, we would like this to do a quick comparison between what tracks get shared the most. So now you have to pass your track ID down to the share button, which makes no sense, because, like for instance, that share button doesn't need that information to do its business logic, but it needs it for analytics. So we basically found a way to get both the aspects that I've talked about so far to work together. So we made aspects work with each other. And the way you do that is the last example I will show you. I've created a trivial example in this case, just to demonstrate the fact that you can have multiple aspects working together. The attached to page view to root aspect. Now what this aspect does could be done inside the page view aspect itself. I'm demonstrating it here as a separate thing just to show the fact that we can do this, and also because what this does, you might not want in some screens. So you might want the page view, but you might not want what this aspect does. And that's the whole point of this, is that you don't get everything that you don't want when you extend, for instance, an activity. You inherit the entire behavior of that activity. In this case, you can get to choose. What this does has this aspect that looks for, in onResume in this case, it looks for the page view object that the page had. Instead of doing something separate, it literally goes, is there a page view in this object? Ah, there is. What is the screen name of this object? I can get the screen name, create an object that contains that additional information that I want all the events in that current screen to have, in this case only the screen name, but you can make this do whatever you want. In our case, we could also put the track ID if there was a track ID provider that can be attached to the screen. And then does something that used to be used a lot in the early days of Android for the wrong reasons, but now doesn't get used a lot. Every view object on Android has the idea of attaching information to it. It's called setTag. There used to be only one method. You used to be able to create an object and put it on the view. Now you can create basically a mapping between IDs and some objects. Now this is, obviously a terrible idea for, doing your business logic, but for view-related data, it's perfect because that is a view and you want to pass around view-related data. In this case, the screen name. So we created an object that contains all the parameters that the screen basically displays and attach it to the root of the hierarchy of the view. We use this by finding the content, Android R content in this case. This is very contrived. You can make this a bit more complex by working on fragments as well. You can get basically the most appropriate object in the hierarchy to attach that special object. In this case, we just went to the top. This view always exists in every Android screen, so we just chose to put it there. And then the page view itself, sorry, not the page view, that was my mistake. The button uses a variation of the event analytics abstraction that we had. Now, usually you can say, send this event, a user event with these parameters. There's also a variation that takes a view that says, send this event from this view with these parameters. This code looks exactly the same like before with the addition of this parameter. If you make this a habit of using that, for instance, in this example, you could always use this version of the event analytics and you would never have to modify the code. This specific implementation does what the previous one did. It's a decoration around the normal event analytics object, but also traverses the view to find that special object that we talked about. So it uses this collaborator to pull that view. And when you have that, you can merge the data that came from the view itself and from the screen view. And you have basically the same button with the same piece of code without any extra work, sending the screen name that it was pressed on. So now, if for instance, I press Smells Like Teen Spirit by track, you see the parameter has the screen name main. And if I open the screen and press it again, I get the screen name second. Now, in an ideal world, you would never have to do this because your data team should be able to, with the timestamps of your events, figure out how many people press the buy button in a specific screen versus in the main screen. But unfortunately, that is not always an option. Many data teams don't have the compute power to do that because, imagine, for instance, at Shazam, we have hundreds of millions of users generating events daily. You can't run basically data analysis all the time. We do run some deep data analysis on some really key metrics that we have, but for things like this, we prefer to basically make the event itself contain all the information that might be needed to generate reports on the fly. This also helps us create real-time views basically of our data. So we have big monitors that say, oh, if there's an event, for instance, that we support, a live event music venue, we will see a spike in how many people view specific screens and view specific artists. And this is how we do it. Now, this was a very small example of how we use this specific library. This library doesn't have to be used for analytics or for ads. It could be used for anything, obviously. But as everything, it's not all roses. There are some problems. So the conclusions. Aspecting is very cool, it's very powerful, but it's not a new idea by any stretch of the imagination. It's been around for a lot of years. And people that have been working with aspects, especially in big enterprise applications, can tell you that in the beginning it seems amazing, everything you can do in such a small amount of work. But that separation, that magic factor of I don't even know how that works, is very dangerous. You have to be very careful when you use that sort of thing. You have to be using it for purely cross-cutting concerns, things that do not interfere with your business logic, and you have to be not be afraid to basically migrate something back into your business code if you see that it has gone a bit out of hand. Like this probably doesn't belong in an aspect, I need to move it back into my code. There are, of course, as I call them, the uber cross-cutting concerns, something that you want to be applied to all your activities. I've mentioned something before that you can create your own base class and apply an aspect there. But that's a bit pointless, like there's no reason to do that. If you want something to happen throughout your application, Android lets you do that already. There is a method on the application object called register activity lifecycle callbacks. They have their own interface that is basically sort of like the aspect interface. You get all the callbacks from create, resume. It's a very cut down version of the callbacks that you get. I think there's like 15 of them or something, so you can't do everything. And you also have to be very careful that this applies to everything. So you can't have, you shouldn't put stuff like page views there because you have activities that you don't always want to send a page view. So interstitial activities or settings, things that you don't care. These are they're very careful things, very specific things that you can use it for. That being said, what do we use all this stuff for? We use the previous example. We use the lifecycle callbacks for user sessions. So we would like to know how long does a user stay inside our app. We can aggregate all the pages that we had, add them together, and figure things out, and do some data analysis to say, oh, these pages are too far apart, so the user must have left the app and then came back into it. But as I said, we don't always have that capability. So what we've done is we've created the idea of that global lifecycle listener, every time an activity starts, it lets that object know an activity has started. And when it stops, it lets it know that an activity has stopped. And that object posts a message 2 seconds in the future or something like that, that basically says, if no other activity has started in the meantime, that is a user session. So you can traverse many activities, and that object gets reset basically every time. So when the user leaves the app, you get a view of the global session of how long did the user stay into my app for that specific session. That is a very specific use case, and that's the only, apart from some other couple things, why we use that. We also use it for some very Shazam-specific behavior that I can't discuss here. It has to do with microphone access and all these things. We use aspects for things like page views and ads, like we've discussed now. We also use them for getting implicit user event parameters. The screen name was an example that I've showed, but we also have things like the track IDs. When you're viewing a screen for a track, we get the information that we want for that track. We persist it in that root object, and then all the events that you do in that screen will have that context around them. We've also created a system whereby, instead of using the normal Android way of launching activities at the time that we want to launch the activity, we have an abstraction that carries information from one screen to the next. So the screen name of an activity becomes a screen origin in the second activity automatically. So any event that you generate, for instance, in that details page will say, oh, the name of the screen is something, but I came from this screen. Because you can come from different places into the same screen in the app. And all that happens automatically. We don't have to do any custom work. That was the whole idea of that, minimize the amount of work you have to do for generating events. We use an aspect to attach fabs to our screens. A fab is a floating action button, for those that don't know. Basically, it's that new paradigm that Android has, where it's basically a floating button at the bottom right of the screen. We have a button that starts basically recognizing a song, and we don't want all screens to have it. We want some of them to have it, but we don't want to have to keep rewriting that code. So that aspect is literally called with floating button. You put it in an activity, and it will find the root view of the activity. It will attach the view on the bottom right. It will handle all the clicks for you automatically, so you don't have to do anything. There's also some very tricky customization you can do. You can provide a parameter to it, to the aspect, with an Android ID that internally is resolved to either a recycler view or a list view, some sort of scrolling container, so that it attaches itself to that. And when you scroll to the bottom of the screen, the floating action button hides itself automatically so that it doesn't obscure content. And all that happens with a single line on the screen. And that code had to be basically rewritten in the past. Now it doesn't. It's one line. We also have a hierarchy viewer aspect for debugging. This is, I don't know if you guys are familiar with this, but Romain Guy from the Android team, not from the Android team anymore, but he used to be. He wrote this little server that basically runs on your phone that allows the debugging tool on your desktop get a hierarchy view of all the views, the widgets that basically you display on the screen. So you can also create a PSD file from it with all the layers. That needs a service running on the phone, and every activity that can provide that functionality needs to do something in onStart and something in onStop. So people used to go and literally go to their onStart method, add that line, go to their onStop method, add that line. Now with a single line, you get that functionality. And also, it knows automatically if you're running in a debug environment or not, so it doesn't pollute the production app. And of course, more to come. So we always keep finding needs for these sort of cross-cutting concerns. And if we find something more exciting, we will probably open source that. Yes, I hope this talk was useful. I gave you some ideas, hopefully. The ideas that were expressed here don't necessarily have to tie into that specific library that we use. If you can use any sort of aspecting framework, you can do the same stuff. You can even do that stuff without aspecting, but there's a bit more manual work involved. You have to basically make something that looks for fields, that implement an interface, and do that work automatically. By the way, this library it doesn't generate code. It runs at runtime, so it picks the annotations up at creation time, and then all the callbacks happen through the normal stack. There's no reflection or anything weird like that happening, so it doesn't really have a big performance penalty. And yeah, I hope you find it not exciting, but hopefully found some ideas useful. And if you can come up with some general purpose aspects that other people could use, I'd love to hear about them, and hopefully we can start building a list of things that, utilities that others can use in their projects. Thank you. Any questions? Yes?
I have a quick question.
Mm-hmm.
I'm not sure if I missed something, because on the beginning you said that sometimes you have these problems with integration with APIs when you have to extend an activity, and even worse, if you have to extend two other activities. And you said that this approach could help us with that, but I'm not sure, still not sure how did you achieve that.
Okay, so yes, I didn't.
How do you get rid of this requirement of extending those activities? Of course, you can delegate those.
Yeah, so I didn't.
To this activity, but how do you create?
I didn't get it. Yeah, I didn't get into details about that. The question is, how does that apply? How does that fix that problem that I mentioned of having to extend two activities? Yes. So if you're integrating with a third-party library, of course, either that third party would have to provide an aspect that does the same work, or most of the libraries that I found, for instance, the Google Maps library used to be one of those things that we had to integrate with. It said, oh, extend this activity. Or, and that's how many libraries do it these days, they say, or make these callbacks, make these calls in your activity. So you can do manually, basically, what that activity does, right? So you can implement your own aspects for third-party libraries as well. So for Google Maps, for instance, I think there were 2 callbacks that you had to do. You had to find a fragment. Well, now they do it with fragments. So you have to find a map fragment into your activity, and then you have to register your activity as a callback listener for that fragment. You can do that with an aspect yourself. You don't have to extend their activity. There's a map activity, I think it's called. But yeah, anything that a custom activity does, if it's open source, you can literally look at that code, remove the extends activity word, make it implements activity aspect, remove all the override and super calls, and you're done. It's exactly the same callbacks. So anything that an open source, at least, library can do inside an activity can be made into an aspect. And if you do that, you can then apply 30 of them in one activity, and you'll get all that behavior automatically. I haven't actually migrated any existing libraries yet to this. This is a very new project, by the way. It was uploaded to GitHub like 3 days ago. So the GitHub project itself is being maintained. I will be creating documentation, and I'll be writing a really nice web page explaining how all these things work. And hopefully, yeah, if we find some libraries that people tend to use a lot and they require you to extend an activity, we can provide basically plugins for them. Any other questions? Yeah?
I had a question about the button that you guys presented. I was thinking because you are posting some truck IDs to use them in the future to some other purpose to register this event and so on. I'm just wondering, because I think I see just a little red alarm blinking in my head when I see that someone is trying to put some truck IDs into the view.
Okay.
Into the button. Why are you not using, for example, your presenter that's specific for a given view to post this data, and you're trying to have it as a parameters of buttons?
Good question. So the question was, in the buy button, I passed the track ID into the buy button. Why didn't I let my presenter do that work? So we used to do that. We used to have our presenters be sort of like God objects that knew everything that was happening on screen at a specific time. We still do that to an extent, but we found out that logic that is replicated across screens, for instance, the buy button is a very trivial one, right? You click it, something happens, but we have things like when you have views that need to display asynchronous data. So you have, for instance, a model that you need to display, and that model contains a URL that you need to hit secondary to get some extra data to display. For instance, we have a tile in the details page of our app that displays YouTube tracks. And because we use the YouTube API to fetch thumbnails and details for those tracks, our model contains a URL to YouTube. So it doesn't contain all the data. Then you display the tile, and then there's a secondary call that does the secondary fetch. That is handled by our top presenter, because that is a very unique view. It only exists in that screen. But if I had to make that view exist in 5 different screens that have completely different business logics, we found that having that logic in the top presenter caused so many problems because A, we had to duplicate that logic, first of all. And the more of these sub-logics that you have, the more complicated your presenter becomes, and testing it is a nightmare. So now what we do is we have views that are used in many places have their own mini presenters. So you wouldn't literally, like here I have bind to and you get the truck ID. If this needed to do an asynchronous call, for instance, like I explained with the YouTube tile, this wouldn't do the network call here. This would have its own presenter. It would start presenting and it would register itself as a callback. So this would be it's sort of a small MVP because that can be reused. That has some downsides as well. Nothing is perfect. But we found that for specific views, like a buy button is like if you open our app, we have buy buttons anywhere, anytime you display information about a track, there's a buy button and a preview button. And that logic would be wasteful to duplicate in many presenters. So yeah, we moved all that logic in the button. And in this case, actually, clicking, because that's why, like ignoring the analytics side of it, this is why I'm passing the track ID here. So when you click it, you do something like launch the Amazon page. That business logic of launching the Amazon page would either live in the top level presenter of the main activity and the second activity, or it would live in a sub-presenter here. And we found that living in a sub-presenter makes more sense. Also, the idea of binding views to data makes your code very simple, because if you look at this second activity, for instance, the second activity has its own presenter, of course, and gets told that the truck was loaded. And you can see, all it does is single line calls. It says, okay, the truck title is the truck title. It binds data to views. In the same concept, the data for the buy button is the truck, or another object that would be a truck dot, get purchasing information. So basically the idea is you bind data types to views, and they're one-liners. And if there's something more complicated, it's hidden inside the view. Anything else?
Did you evaluate the annotation processor instead of aspects?
So the if we used, you mean if we've used the annotation processor, or if we can make this use the annotation processor?
Did you evaluate it as an option?
So we thought about that. We thought about code generation because many libraries use code generation now. There was a time where, as a team, we were a bit against the idea of code generation. We don't like code that we didn't write because we find it harder to debug, and we thought that other people might also feel the same. But also, at the time that we wrote this, we found that the only downside to this, performance-wise, is during the creation of your activity instance or your fragment instance. Because if you look at the aspect activity, I can actually show you the code. It's open source. So right, aspect activity. So all the work that might take some time to execute is this line. So when your activity instance is created by the system, you create a dispatcher, the idea of an object that delegates the callbacks to the listeners. And that is the thing that uses annotation, not processing, but a runtime annotation retrieval. Right? There is a get annotations object basically here that retrieve annotations. This is reflection, and this is done only at creation time. So if you have an object that has two lifecycle listeners, actually, if you have one aspect annotation with 2 lifecycle listeners, you only do one reflective call to get a list of objects. Everything else is done via the stack, because the dispatcher is now an object that lives in memory, and when you call methods to it, it literally just calls them. It doesn't do anything weird. It doesn't do reflection afterwards. We have not noticed any performance downside to this, so that's why we haven't done this. If over time we found that there is actually a problem, or if people want to use this library and they don't like the idea of doing reflection at creation time, we could provide 2 modes for this to be working on. Because this is just a mechanism of getting the annotations, right? That after you get them, the code will be the same. So you can do this with code creation or with runtime annotation retrieval. So we can do that. We just haven't. Any other questions? No? Okay. Well, thank you very much. And yeah, please do go to the project and comment or star it or download it or give any feedback. Thank you.